So in this video I am going to explain about geostationary satellite. What is geostationary satellite? If a satellite revolves in a equatorial plane in the direction of earth rotation from west to east is the direction of earth rotation, okay, with a period of revolution equal to time period of rotation of earth on its own axis, and that is 24 hour, then satellite will appear stationary relative to earth. Such a satellite is called geostationary satellite. Okay, very simple definition. If any satellite have direction and period of revolution same as period of revolution and direction of rotation of earth, then this kind of satellite appears stationary, sorry uh, appear stationary relative to earth. Okay, so this kind of satellite is called geostationary satellite. Okay, now the next point, such satellite revolve around the earth at a height of 36,000 kilometers. So this is very important point. What should be the height for geostationary satellite? 36,000 kilometer. Okay, the orbit of geostationary satellite is called parking orbit. Okay, Arthur C. Clarke was the first to predict a communication satellite can be stationed in the geosynchronous orbit. Okay, so this is also one of the important point. So the important point is where should be a communication satellite stationed. So it should be stationed in the geosynchronous orbit, and who given this logic? Arthur C. Clarke. Okay, and the orbit of geostationary satellite is called parking orbit. So all are very important point. Now the next point is escape velocity. Escape velocity is that minimum velocity with which a body should be projected from the surface of earth so as it goes out of gravitational field of earth and never return to the earth. So this is very important point. Okay, escape velocity is the minimum velocity with which a body should be projected from the surface of earth so as it goes out of gravitational field of earth and never return to earth. Okay, escape velocity is independent of mass, shape and size of body and its direction of projection. Okay, so this is very important point. Escape velocity is independent of first mass, shape, size of body and its direction of projection. Okay, escape velocity is also called second cosmic velocity, and for earth escape velocity is 11.2 kilometer per second. Very important. For earth escape velocity equal to 11.2 kilometer per second. For moon escape velocity is equal to 2.4 kilometer per second, and orbital velocity of satellite, it's a root zr, and escape velocity of any satellite root under 2zr. Okay, so where r is equal to radius of the earth. Okay, so escape velocity, so the relation between escape velocity and orbital velocity is root 2 escape velocity is equal to root 2 orbital velocity. So escape velocity is root 2 times the orbital velocity. So it means if the orbital velocity of satellite is increased to root 2 times, the satellite will leave the orbit and escape. Okay, so this is about escape velocity, which comes under geostationary satellite section only. So let me revise the all thing. Okay, first geostationary satellite height should be 36,000 kilometer. Okay, and communication satellite can be stationed in geosynchronous orbit. This logic given by Arthur Clarke. Okay, next point, geo direction and speed of rotation of geostationary satellite is same as Earth. Okay, now come to the escape velocity. For Earth 11.2, for Moon 2.4, Moon 2.4, Earth 11.2, orbital velocity root zr, escape velocity root 2zr. Relation between orbital velocity and escape velocity, escape velocity is equal to root 2 into orbital velocity. So it means escape velocity is root 2 times the orbital velocity. So if orbital velocity of any satellite increase to root 2 times, then that satellite will escape from orbit. Okay, will leave the orbit and escape. So that's all about satellite, geostationary satellite. So in the next video I will explain all important points related to pressure. Thank you.